Hi, I'm Raina Fitzgerald, and in this lesson, we're going to be looking at working with fractions. We're going to start by looking at reducing fractions. Then we're going to look at converting between mixed numbers and improper fractions. And then we'll end with performing operations with fractions, including addition, subtraction, multiplication, and division. Let's start with reducing fractions. We have 24 divided by 36. This is a fraction. It has a numerator and a denominator. So let's label these. Okay, the top is called the numerator, and the bottom is called the denominator. Now if you look at these, this is not fully reduced. And what we need to do here is we need to reduce it down by finding common factors that are in the numerator and the denominator. So let's take a look. Let's do some prime factorization for 24 and 36. So to factor these, what we want to do is we want to start pulling out all the prime numbers. So the first prime is 2, and a prime number is a number that is equal to only the product of itself and 1. It is not equal to the product of any other two numbers. So 2 goes into 24 12 times, and 2 goes into 12 6 times, and 2 goes into 6 3 times, and now we have all the primes. 24 is equal to 2 times 2 times 2 times 3. Let's do this with 36. 36 is equal to 2 times 18. 18 is equal to 2 times 9. And 9 is equal to 3 times 3. And so that means that 36 is equal to 2 times 2 times 3 times 3. This is a tree structure diagram where the bottom of the tree structure gives us the prime numbers such that the product of these prime numbers is equal to 36. And the product of these 4 prime numbers is equal to 24. So let's go ahead up to our fraction and let's put what 24 is equal to. It's equal to 2 times 2 times 2 times 3, and 36 is equal to 2 times 2 times 3 times 3. In this particular case, we can cancel out any like facts. So this 2 cancels out with this 2. The 2 in the numerator here and the 2 in the denominator cancel out. The 3 in the numerator here and the 3 in the denominator cancel out, giving us our reduced fraction. And our reduced fraction is 2 divided by 3. So we pulled out a common fact, and if we wanted to know, well, what is that common fact? Well, looking at the numerator, what we canceled out was 2 times 2 times 3. Oh, 2 times 2 is 4, and 4 times 3 is 12. So the common factor in both the numerator and the denominator, in both 24 and 36, is 12. 24 is 12 times 2, 36 is 12 times 3. Now we're going to look at what is an improper fraction and what is a mixed number. So let's start with an improper fraction. An improper fraction is a fraction such that its numerator is greater than the denominator. So 30 over 6 is an improper fraction. Another example would be 20 over 4. That's an improper fraction. And finally, another example might be 6 over 2. That's an improper fraction. And the reason that they are improper fractions is because the numerator here, all our numerators are greater than the denominators. The 20 is greater than 4, 6 is greater than 2, and 36 is greater than 6. Now let's take a look at what is a mixed number. So we'll move our question mark in. A mixed number is expressed as a whole number value. Here's our whole number, which in this case, I can make it negative. That makes it an integer. So the whole number can be an integer. We'll stick with, for now, a whole number. 6 2/3. This is a mixed number. And the reason it's mixed is because it has both a whole number, or integer part, and I'll call it integer because it can have a sign, a negative sign in front of it. So it has an integer part, and it has a fractional part, and therefore it's considered a mixed number. We'll write a couple of other mixed numbers. 5 1/3 is a mixed number. 6 1/2 is a mixed number. So this is just to give you an idea of when you see improper fraction, you know it means that the numerator is greater than the denominator. And when you see mixed number, that means it's made up of two parts, a whole number part and a fractional part. Now we're going to convert between mixed numbers and improper fractions. Okay, so let's start with 2 1/3. This is a mixed number because it has a whole number part, which is 2, and a fractional part, which is 1/3. And what we want to do here is we want to take the denominator of the fraction and we want to multiply it by the whole number part. That's multiplication. And we want to take the result of that and add it to the numerator. So let's do just that. We want to take the denominator 3, we want to multiply it by the whole number part, which is 2. We're going to do that first. And then we're going to add the numerator, which is 1. The denominator stays the same. Well, 3 times 2 is 6, and we have 6 plus 1 divided by 3. And 6 plus 1 is 7, so it's 7/3. So what we have here is we started with a mixed number that had a whole number part and a fractional part. We end up with a fraction, and this is an improper fraction where the numerator is greater than the denominator. So let's try going the other direction. So I have 22 divided by 3. In this case, I have an improper fraction. So I want to convert my improper fraction to a mixed number, and that's going to require division. I'm going to have to divide 3 into 22. Well, I know that 3 goes into 22 7 times. 7 times 3 is 21. And 22 minus 21 is 1, so I have a remainder R of 1. So 22 over 3 is equal to 7. This is our 7. Put that 7 in. 7 and our remainder of 1 over 3. So here we started with an improper fraction where 22 is greater than 3. So the numerator is greater than the denominator. And the result is a mixed number where we have a whole number part and a fractional part. So these are the directions for converting between mixed numbers and improper fractions. Now we're going to look at adding two fractions. And if we look at these two fractions, their denominators are not the same. 2/3 has a denominator of 3 and 1/4 has a denominator of 4. So what we're going to have to do here is we're going to have to change these up a little bit so that the denominators are the same. So here I have 2/3, and here I have, and that's being added to 1/4. And if I look at how they factor, 3 is actually just equal to 3 times 1, and 4 is equal to 2 times 2 times 1. This is the prime factorization. So they have nothing in common. So what I'm going to need to do is I'm going to need to multiply the top and the bottom of each fraction by the same thing. And that is, I'm going to have to multiply the first fraction by 4/4 and the second fraction by 3/3, so that what they end up with is they both have the same denominator, which is 4 times 3. So what's going on here, though, if you look at this, is that this fraction right here, 4/4, is equal to 1. So when you multiply 2/3 times 1, it maintains its value. The multiplicative identity of 1 says if you multiply anything by 1, it keeps its value. So we're not changing the value of 2/3 when we multiply 2/3 by 4/4. And the same thing happens with 1/4. We have 1/4 here, and we take 1/4 and we multiply it by 3/3. Well, 3/3 is 1. So if you multiply 1/4 by 1, the multiplicative identity of 1 says that 1/4 keeps its identity. So when we do this, what we get in the numerator of the first fraction is 2 times 4, which is 8. And then in the denominator, 3 times 4, which is 12. And then in our second product of two fractions, we have 1 times 3, which is 3, over 4 times 3, which is 12. Okay, we're halfway done because now our denominators are the same. If your denominators are the same, then you can add the fractions together with the same denominator, and what you do is you add the numerator, 8 plus 3. And we end up with 8 plus 3 is 11, and our answer is 11/12. So here we have it, 2/3 plus 1/4 is equal to 11/12. Now we're looking at subtracting fractions, and it's very much like adding fractions. The difference is we have subtraction, and so what we want to do is we want to change the subtraction to add or addition of the opposite, which means what we have here is I'm now adding a -1/3. So let's move forward with this, and what we need again is we need a common denominator. So we have 2/9, and 2/9 we're going to add a -1/3, and we need to evaluate the denominators to determine what the common denominator would be. Well, if we look at 9, 9 factors into 3 times 3. Those are its primes. That's its complete prime factorization, 3 times 3. And 3 factors into just 3. They're both times 1. So what they have in common here is this 3. They have a 3 in common right here. So what we need to do is nothing to the first fraction, but to the second fraction, we need to multiply it by another fraction, which is equal to 1, and it's going to have a 3 in the numerator and a 3 in the denominator. So what we know is we know that 3 over 3 is equal to 1. So if we take a negative 1/3 and multiply it by a 1, the multiplicative identity of 1 tells us it will stay a negative 1/3, but it will be expressed differently. So this becomes 2/9 plus negative 1 times 3 is a negative 3, and in the denominator, 3 times 3 is 9. So now we have common denominators. They're both 9, so we can add these together under the common denominator of 9. And in the numerator, we have 2 plus a negative 3. So we're adding numbers that have different signs. When you add numbers with different signs, positive 2, negative 3, you actually take the difference. The difference between 2 and 3 is 1, and the sign that you give it is the sign of the larger digit. 2 is smaller than 3, so the sign we give it is negative. So 2 plus negative 3 is negative 1, and in the denominator we have a 9. So our result is that 2/9, that was a minus 1/3, which is plus a negative 1/3, is equal to a negative 1/9. Here we're multiplying two fractions. We have 3/4 multiplied by 1/2. And this is, multiplying fractions is very straightforward. We multiply the numerator 3 times 1, and 3 times 1 is 3, so we'll write out our multiplication. It's 3 times 1. And then we multiply the denominators, which are 4 and 2, so it's 4 times 2 in the denominator. And we end up with 3 times 1 is 3, and 4 times 2 is 8. So here our product is 3/8. Let's try another one. I'm going to move this down a little bit. I guess not. We'll leave it there. Okay. So let's try another one. Say we have 5 over 3, and we're going to multiply that by 2/3. Well, that's going to be 5 times 2 divided by 3 times 3. 5 times 2 is 10. 3 times 3 is 9. Let's try another. Let's say now we're multiplying 15 over 2 times, let's say, 7 over 3. Well, that gives us 15 times 7 over 2 times 3. Well, wait a minute. There's something else I'm seeing happen here. I notice that 15 is 5 times 3, and there's a 3 in the denominator. So let's move forward and let's factor 15. 15 is 5 times 3. So I'm going to write that out. 5 times 3, that represents the 15, and I'm multiplying that by 7. And in the denominator, I have 2 times 3. And what I'm noticing is that I have a 3 in the numerator and a 3 in the denominator, which means they can cancel out, which gives me 5 times 7, which is 35, divided by 2. Now let's take a look at our results here. In our first multiplication, when we multiply, we end up with 3/8, which is a fraction. In our second multiplication, when we find the product of these two fractions, we end up with 10 over 9, which is an improper fraction. Well, we can simplify this further by doing the division, because I know that 9 goes into 10 once, and 10 minus 9 is 1. So it's 1 with a remainder of 1, which means that this fraction is equal to 1 with the remainder of 1 over 9, 1/9. So I was able to take the product of my two fractions, find its product, which was an improper fraction, and turn it into a mixed number. So here, let's look at the bottom, was a product of two fractions. I was able to do some reduction, and I got my improper fraction. And let's go ahead and take this improper fraction and convert it into a mixed number. So we want to divide 2 into 35. And I know that 2 goes into 3 once. So 1 times 2 is 2, and we subtract. 3 minus 2 is 1. 2 goes into 15 7 times. 7 times 2 is 14. 15 minus 14 is 1, so I have a remainder of 1. So this fraction is equal to 17 with the remainder of 1 over 2. And there we have it. The product of 15 halves over times 7 thirds is either 35 halves or 17 and 1/2. Now we're going to divide fractions. And dividing is pretty straightforward when we keep in mind what division means. Division means multiply by the reciprocal. So let's write that down. Let's abbreviate multiply by the reciprocal, which is the inverse. So what we're saying is, instead of saying 3/4 divided by 1/2, that's the same as saying 3/4 multiplied by the reciprocal of 1/2, which is 2 over 1. So what we're doing is we're going to multiply the 3 times the 2 over 4 times 1. And I hope you're recognizing that we happen to know that 4 is 2 times 2. So I can rewrite the denominator as 2 times 2 instead of 4. And what I see here is that the 2's cancel out, and I end up with a 3 in the numerator, and 2 times 1 is 2, so 3/2 in the denominator. So my result is that 3/4 divided by 1/2 is equal to 3/2. Okay, let's try another one. 5/9 divided by 2/3 is the same as 5/9 times the reciprocal of 2/3, which is 3/2. Now you might just see right away that there's a 3 in the numerator and a 9 in the denominator, and of course 9 is 3 times 3. So I end up with 5 times 3 in the numerator and 9 times 2 in the denominator. Let's write that again as 5 times 3 in the numerator. In the denominator, my 9 is really 3 times 3. So that's my 9 times 2. And I did that so you can see that I'm canceling out these two 3's. And I end up with a 5 in the numerator and 3 times 2 in the denominator, which is a 6. So 5/9 divided by 2/3 is 5/6.